Hello, welcome to the first chemistry lesson with me, Aaron, and Dylan. We will be talking about states of matter and phase changes. So let's get started. So first of all, what are states of matter? Simply put, they are the physical states of a chemical compound, specifically more at a molecular level. There are four fundamental states. The three most common are solids, liquids, and gases. The fourth state is plasma, which is pretty much a superheated gas that is ionized and thus can conduct electricity. The difference between plasma and gas is primarily nomenclature, as plasma is essentially a gas in all but the ionization. Um, each state has its own unique physical and chemical properties that make it unique from the other three, which is why these are
Phase changes are the process of
fundamental.
changing a compound from one physical state to another, and they occur at a certain temperature of each different element and compound. When it reaches that certain temperature, it will either boil or melt. And those temperatures, which was stated earlier, they're unique to each different compound and element, and they signify when a compound will undergo one of these phase changes. And additionally, the temperature at which compounds undergo a phase change is the same in either direction. So the freezing and melting point of a compound are the same value.
Okay, so solids. Solids are essentially a grouping of atoms that are tightly packed together and they don't move freely relative to the other atoms. This is common in like salts where you have the lattice structure that in which molecules are bonded together, and you have ice in which water molecules are bonded together. This is an example of a solid. The structure of a solid is not permanent in the sense that it can be reformed or changed by an outside influence, but they retain their shape and bonding to each within the structure to each atom. And some of the characteristics of this, they have a definite shape or volume unless like molded differently by like a human. So if you were to bend metal, it's still a solid, it's just malleable. Um, Generally, they are more dense. However, water is an exception, as ice is actually less dense than liquid water because of the way it freezes together and the molecules orient themselves due to water's polarity. And lastly, the particles are closely packed together and retain their position in relation to each other. So those are the defining characteristics of a solid.
And the next characteristics are about liquids, and like solids, they are a grouping of atoms bonded together with a fixed number of molecules. However, liquids have the ability to move freely, and as such do not retain a fixed position. This also means that they can take the shape of their container, as they cannot form a fixed shape on their own. So some characteristics are they take the shape of its container, and the molecules move freely relative to each other, and they flow, meaning they will change shape due to external forces. So, for example, if you were to tip a bottle of water, the water would shift in position with the glass.
Gases are somewhat similar to liquids in that they do not retain a fixed volume or shape. However, they expand to fill whatever space is available to them. So gases in the atmosphere expand and fill the atmosphere. Um, and they don't have liquids like solids actually do have some they don't move completely free because they have some intermolecular forces attracting to each grouping of atoms or molecules. Gases are not like this. They just kind of go wherever in the space afforded to them. And as such, they have a very low density and exist at high temperatures usually. Gases are unique because they have unrestricted movement and fill up space. The primary characteristics are they have very low density because they expand. They move freely in any space they are given. They don't have a fixed volume or shape, and they're often colorless and odorless. This is not always the case, obviously, but the gases that make up our atmosphere are colorless and odorless. And one more thing, the density is of a gas is dependent usually on its container. So if if a large amount of gas is placed in a small container, because the gas is packed together so tightly in such a small volume, the density will actually be very high. So that density is only for large areas where there's essentially no restriction on the volume of gas, like our Earth's atmosphere.
So another type of gas, which is actually a fourth state of matter, is plasma, which is superheated matter, and it's so hot that the electrons are ripped away from the atoms and molecules that make up the gas, and this makes it an ionized gas. So the superheated ionized gas is it's known as plasma, and the fourth fundamental state. It conducts electricity and has no definite shape or volume if outside a container, like already stated, like Aaron.
Okay, so these are the phase changes, which just means these are the how molecules go from one phase to another. So you should already know a solid melts to a liquid, and a liquid freezes into a solid. And then evaporation and condensation, a liquid evaporates into a gas, and a gas condenses back into a liquid. Like we said earlier, the temperatures at which these phase changes occur are the same in either direction. And then, for example, sublimation and deposition are a solid going directly to a gas, and a gas going directly to a solid. This isn't necessarily common naturally, but it would be like if you put gas in like a freezer or something like that, and then it just froze directly into a solid. Not super common in nature though. It does not occur naturally in the water cycle, I don't believe. Actually, correct that. It does occur naturally in the water cycle when snow sublimates into gas, but not super common.
So here's a hypothetical situation of phase change. So filling up a pot of liquid water, and it's placed on a stove, and the heat is turned on. And so the boiling point of water is 212 degrees Fahrenheit. So you leave this pot of water on the burner until it reaches 212 degrees Fahrenheit. And once this happens, the water will evaporate into the atmosphere, now becoming a gas and undergoing a phase change. And the water will begin to bubble as well, boiling point. And this is part of the process of evaporation. And that's the situation for phase change of water.
Yeah. Thank you for coming to our amazing presentation on phase changes. If you have any questions, we will be able to answer those in the future. So thank you for watching.